Our tour of instruments utilized in forensic science laboratories begins with the Gas Chromatograph Mass Spectrometer, often referred to as the GCMS. Many forensic science disciplines apply gas chromatography mass spectrometry for the analysis of casework samples. GCMS is used to analyze residues from fire debris for the identification of an ignitable liquid and explosion scenes for the identification of low or high explosives. It's also used to analyze evidence to identify whether it contains a controlled substance and to identify and determine the concentration of alcohol and controlled substances in body fluids. This is an image of the Gas Chromatograph Mass Spectrometer. During analysis, a sample is placed in a vial that sits in the autosampler. When the analysis begins, the autosampler will position the vial in the autoinjector. A microliter of the sample is drawn into the syringe and then injected into the gas chromatograph. In the gas chromatograph, the sample is vaporized, compounds are separated, and carried to the mass spectrometer. In the mass spectrometer, the molecules are ionized, separated, and then detected. Here is a diagram of the interior of the instrument. As we just described, the sample is vaporized in the heated inlet and the compounds separated on the column, which is contained in an oven. The compounds enter the mass spectrometer through the transfer line into the ion source. The molecules of the compounds are ionized in the ion source and repelled into the mass filter that separates them based on their mass-to-charge ratio. The separated ions are multiplied and then converted into an electronic signal in the detector. Compounds suitable to gas chromatography must have sufficient volatility, withstand high temperatures, and rapidly form a vapor without degradation or interaction with other compounds. Sample preparation is dependent on the type of sample. Compounds in the gas phase are directly injected. Liquids and solids must be prepared. The simplest preparations are dilution of liquids which vaporize in the inlet, or for solids, dissolution followed by vaporization in the inlet, or collection of headspace vapors followed by direct injection.